Welcome to the Chapter 7.1 lesson video. We're going to be talking about sequences and series in this lesson, which are patterns of numbers that relate to each other. Essentially, they are lists of numbers that have a pattern or a common change between them. And so we're going to dive into that. Let's go ahead and get started. All right, so today we're going to be talking about using sequences and notation and series notation. We can write rules for the nth term. We'll talk about what that means. And we can sum up the terms into something called a series and use summation notation. All right, so a sequence. So a sequence is an ordered set of numbers where each number is called a term of the sequence. This is what we call an explicit sequence. So this is the first term. We can call it A1. The second term we can call A2. The third term we can call A3. The fourth term A4. And the fifth term A5. So on, so on. Sequences can either be infinite or finite. Infinite meaning ... we don't see the rest. Finite meaning it ends and we know it's the end. All right, so this is a explicitly defined version of a sequence right here. It says that a sub n, so the term n, right? N is just a placeholder. So the nth term is equal to whatever term number it is plus 4. Okay, so let's go ahead and talk about this. So the problem says to find the first 6 terms. So we're going to go ahead and find A1, A2, A3, A4, A5, and A6. Okay, so in order to find these terms, we're going to take the term number, the number in the order that it is, and add 4 to it. So 1 plus 4, 2 plus 4, 3 plus 4, 4 plus 4, 5 plus 4, 6 plus 4. Now, you don't have to show it like this every single time. This is just me going into a little bit extra detail of how an explicit sequence works. And so then we just write them in order with a list. So that is 5, 6, 7, 8, 9, 10, and a ... because we assume that it's going to continue going on from here. So these are the first 6 terms of our sequence, 5, 6, 7, 8, 9, 10, in that order. And we got it by taking the term number and adding 4 to it. Term number, adding 4, term number, adding 4, term number, adding 4. And that's this explicitly defined sequence form right there. Another way we can define a sequence is with something called recursive. So think about this, recursive. So recursive. So it's like re and curling. Those are the kind of 2 words that I hear in there. So the way you can kind of think of recursive is that each next term is defined based on the previous term. So you got to use the next term or the previous term to get the next term. So it's kind of recurling on itself. So recursively defined sequences are given so that finding each new term depends on knowing its prior term. So I can only find the 6th term if I can look back and know what the 5th term was. I can find the 7th term by looking back and knowing what the 6th term was, and so on and so on. So these are listed a little bit differently. These ones, they usually give you one of the terms. So they say like the first term is 3, and then they say any future term is equal to 12 plus the term before it. That's what this notation says. So this is the nth term. This is the nth minus 1. So it's 1 before the nth term. So if this was A7, this would be A7 minus 1 is A6. You would use the 6th term. You would add 12 to get the 7th term. So for this example here, A1 is 3. They give us the first term. A2 is the 3 plus 12. So it's the term before plus 12. So 3 plus 12 is 15. Then the next term, we use the previous term. 15 plus 12 is 27. The next term, 27 plus 12 is 39. The next term, if we were to do this again, 39 plus 12 is 51. And we could keep going. We just add 12 each time we move on. But in order to know the next term, you have to know the previous term. So this one, you can tell it's the recursive form because they give you one of the terms. And then notice we're not plugging it in here. We're plugging the whole thing. And we're saying this whole thing right here is the previous term to get the next term. All right, so let's go ahead and try one. So let's try, it says find the first 4 terms. And this sequence says that the first term is 2. So we already got one of them. So we'll say the first term is 2. And then it says in order to find the next term, you need to take the previous term. Ooh, a little more complicated. To find the next term, we need to take the previous term, divide it by 2, and square it. Okay, so we take the previous term, divide it by 2, and square it. So it's going to take a little bit of math, and that's okay. So we would take the previous term, that is 2, divide it by 2, and square it. 2 divided by 2 is 1. 1 squared is 1. Bam. That's the next term. Then, to get the next term, we're going to do the same thing. We're going to take the previous term, which is 1, divided by 2, square it. 1 over 2 squared, that's 1 times 1, over 2 times 2, that's 1/4. Do it again. We're going to take the next term, 1/4, divide it by 2, and square it. A little more math here, that's 1/8 squared, which is 1 times 1 over 8 times 8, which is 1 over 64. And we can keep going with this process. We always just take the previous term, plug it in. So, right, this says this is the previous term. So if we're looking for the third term, we take the third minus 1, which is second term, divide it by 2, and square it. Keep on going. You just use the previous term to get the next term. Okay, so that's called a recursively defined sequence. All right. So explicitly defined sequences are given so that finding each term depends on what number the term the sequence is. So we talked about this a little bit already when I first talked about sequences, but just to give it a little more of a definition, an explicit rule says, hey, for the fifth term, you're going to take the number 5, right? This is now taking n, whatever the little subscript here is, and plugging it into the formula. So for the fifth term, you're going to take 5 times 12 minus 9. So that's 60 minus 9 is 51. So you can have the same sequence defined both explicitly and recursively. That is a thing, but they're just different ways of describing the same thing. So for the first term, we take the first term, we say 1 times 12 is 12, minus 9 is 3. 2 times 12 is 24, minus 9 is 15. 3 times 12 is 36, minus 9 is 27. 4 times 12 is 48, minus 9 is 39. So you're just saying, whatever the term number, the 11th term, 12 times 11, minus 9. Okay, so you're just plugging in whatever the subscript is into the formula that is given. All right, so let's go ahead and give it a try with this one right here. It says find the first 5 terms. Now, when I do ones like this, sometimes I like to just say, all right, so first 5 terms. So I'm doing A1, A2, A3, A4, and A5. All right, then I'm going to take that little subscript from each of those terms and plug it into this formula that they give us right here. So the first one I'll do is 1 times 1 plus 3, and then 2 times 2 plus 3, and then 3 times 3 plus 3, and 4 times 4 plus 3, and 5 times 5 plus 3. I'll then go through, I'll calculate each of those. So 1 times 4 is 4. 2 times 5 is 10. 3 times 6 is 18. 4 times 12 is 48. And 5 times 8, I did that wrong. Sorry, back that up. 4 times, not 12, that's 4 times 7. 4 times 7 is 28. Yep, 4 times 7 is 28. And then 5 times 8 is 40. Okay, and there's my sequence, the first 5 terms. I just figured out by plugging in the subscript from each of the terms 1 into this formula that they gave us, then 2, then 3, then 4, and so on and so forth. All right, well, so this next one says, hey, let's try and write an explicit formula. So this does take a little more challenge, or this is a little more challenging. This does take a little more time. You gotta have to figure out what the pattern is, what's happening, how do we get there. This isn't something we're gonna see a ton of, but it is something that you should try and do and be able to do. So we have 1, we have 3, 7, 15, 31. And so there's a lot of different patterns and you learn to recognize them a little bit. And as I look at this one, what I learned to recognize is that 1 is often the power of something or have something to do with a power of something. And so I start looking at them and I'm thinking about powers and I start to notice, hey, this is really close to 2 and then 4, that's really close to 8, 16, 32, they're all 1 less than powers of 2. So I think I know what this is. This is AN equals 2 to the nth power, but 1 less than it. So each term is a power of 2, but it's 1 less than a power of 2. And it's just one of those things that as you learn patterns, you start to see these things more and more. You start to see the difference between them more and more and recognize them. There are some strategies and different strategies, and that's something we go over a little bit later in the chapter. For now, do your best, try and figure out a pattern, but some of them are a little trickier and harder than others. All right. Now, another thing that you'll see in this chapter is something called a series. Now, a series is the result of the indicated number of terms in a sequence being added together. So series means add them all up. Okay, so when I see S sub n, it means the sum of the first n terms in the series. So S sub n means you add up terms 1 through n. So in this example, S sub 5 means you add up terms 1, 2, 3, 4, and 5. You add them all up to get the first 5 terms of the series summed up. So you add up the first 5 terms of the sequence to get the series of the first 5 terms. So when you see series or you see this S sub notation right here, it just means add up the sequence. All right, another way you will see series notated is with something called sigma notation. So sigma notation is used as a shorthand as well to tell that we add up the values of a given explicit formula. So what this says is you add up the terms from the first term to the 10th term for this formula right here. So you'll plug in 1, you'll plug in 2, 3, 4, 5, 6, 7, 8, 9, 10, and then add up all those different numbers. And that's what sigma notation means. So for example, I won't do the whole thing, so it'll take me a little too long. You would take 4 times 1 plus 1, that's the first term, and add it to 4 times 2 plus 2, and add it, and you'll keep doing that until you get to 4 times 10 plus 1. Sorry, made a little mistake back here. It's not a plus 2, that's a plus 1. And you'll do that all the way up until you do 4 times 10 plus 1. You'll add those all up, and that is the series from 1 to 10 for that specific sequence, for that specific formula, or that explicit formula for a sequence. So this uses what's called sigma notation. So we got 2 samples here. The first one says, write this series using sigma notation. All right, so we'll go ahead and we'll start by drawing the sigma symbol. That's a good place to start. So we start with the sigma. So we draw the sigma sign. All right, and we'll say, let's use the letter K. So we say K equals, we're going to start with our first term, and we count how many terms there are. There's 1, 2, 3, 4, 5, and we'll go to the 6th term. So the bottom number is the starting place, and the top number is the ending place. And then we've got to figure out what the pattern is here. And this one's hopefully a pretty simple one. So we have 5, 10, 15, 20, 25, 30. So this is just multiples of 5. So our pattern will be K times 5. All right, so that's our sigma notation here. We're going from the first term to the 6th term, and it's really just the term number 1 through 6 times 5. Now, say you don't like the letter K, you can use any letter you want. So I could change this to be N. So I could say N equals 1, and then n times 5, it doesn't really matter, or you can say 5n. Well, and if you want to do the series here, you'll just add these numbers up. So you'll say 5 plus 10 plus 15 plus 20 plus 25 plus 30. And if you add those all up, you get 35 times 3 is 105. And we'll talk a little bit later in the chapter about easier ways to add them up other than just pulling out a calculator and typing them all in. But for now, that is a sufficient way to do this. All right, our next example on here, it says, write out this series and then find the sum. All right, so we're going for the 4th term through the 8th term. It's okay, we don't have to write the first 3 terms. We can just start at the 4th one. And the terms are 3 plus the term squared. Okay, so we'll go ahead and we'll start with the 4th term. So 4 squared is 16. 16 plus 3 is 19. Plus, the next term would be the 5th term. 5 squared is 25, plus 3 is 28. Plus The next term is 6 squared is 36 plus 3 is 39. Plus, the next term would be the seventh term. The seventh term, 7 squared is 49. 49 plus 3 would be 52. Plus, finally, the eighth term. 8 squared is 64 plus 3 is 67. All right, so there are our 5 terms of our sequence. We just plugged in 4, we plugged in 5, we plugged in 6, we plugged in 7, we plugged in 8, and now we're going to add them all up. Now, this may take you just a few seconds. You got to type it all on your calculator. So 19 plus 28 plus 39 plus 52 plus 67. You add those all up, and you get that the sum of this series is 205. All right. So there we go. That's sigma notation for series. You can use it to condense down a series and write it a little bit smaller. That's what we did up here. Or you can use it, you can expand it, you can figure out what the terms are, and then figure out what the sum actually is. All right, and with that, that should be enough information for you to be able to get started now. I'd encourage you, go ahead and look at the assignment. The more you practice these, the easier they will get. If you have any questions, please reach out to me. Otherwise, I'll see you in our next live session. And until then, I hope you have a great day.